Hi, welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. This is Guntuka Srinivas. This is a free online educational channel, mainly concentrating on the basic concepts associated with the physics, chemistry, and mathematics subjects. In the previous session, we have seen the concept of acceleration and the graphs related to it. In the present session, let us take up some numericals related to acceleration. Related to acceleration. Let me take up the first numerical. Find average acceleration. Find average acceleration in between, that is from 0 to 3 seconds. 0 to 3 seconds. If velocity is given as 2t square minus 4t. 2t square minus 4t. Velocity expression is given this. It needs average acceleration and time is in between 0 to 3 seconds. From 0 to 3 seconds. Now, E is interested in the average acceleration. So, what is the formula for acceleration? Average. AB stands for acceleration, average acceleration. So, delta V bar, change in velocity, by delta T, change in time. Numerator change in velocity, denominator is change in time. Change in velocity by change in time. That means V2 bar minus V1 bar by T2 minus T1. T2 minus T. This was the simplified expression. Clear? Now, observe. E requires average acceleration in between 0 to 3 seconds. In between 0 to 3 seconds. Here, 0 to 3 seconds means T1 is 0 seconds and T2 is 3 seconds. T1 here is 0 seconds and T2 is 3 seconds. In between 0 to 3 seconds, it requires average acceleration. Clear? Now, observe. When T1 is 0 seconds, the corresponding velocity is, we are denoting it as V1 bar. V1 bar. When T1 is equal to 0 seconds, the corresponding velocity is V1 bar. And that is, expression is given 2t square minus 4t. This was the expression. Clear? This was the expression given to us. Just in place of t, substitute t1 0 second. So this becomes 2 into 0 square minus 4 into 0. So this becomes 0 meter per second. So V1 bar is V1 bar is 0 meter per second. This is the first step. Clear? Now, observe. When T2 is 3 seconds, the corresponding velocity V2 bar, we are naming it. Same expression, 2t square, velocity expression is same, 2t square minus 4t. But in place of t, we are substituting T2, that is 3 seconds. So 2 into 3 square minus 4 into 3. So 9 into 2, 18 minus 12. So becomes 6 meter per second. So V2, here it is V1 is 0 meter per second. Here V2 bar is 6 meter per second. This is the second step. So observe carefully. When time t1 was 0 seconds, corresponding v1 bar was 0 meter per second. When time t2 3 meters 3 seconds, and corresponding v2 bar velocity is 6 meter per second. Step 1 clear. Step 2 we have calculate t1 t2 v1 bar v2 bar. Clear? No. We are substituting in the given formula, that is average acceleration is v2 bar minus v1 bar by t2 minus t1. The expression here. So v2 how much got? v2 was 6 meter per second and v1 was 0. And time t2 was how much? 3. And t1 was simplifying 6 by 3. This becomes 2 meter per second. So average acceleration is 2 meter per second square. This is the answer. In between 0 to 3 seconds. From 0 to 3 seconds. 0 was t1 seconds. G3 was t2 seconds. Corresponding velocity v1 bar, v2 bar. Change in velocity v2 minus v1 bar divided by t2 minus v2 bar. That gives us average acceleration. Clear? Let me take up the second numerical. In this case, that is displacement S is given by T cube minus 6t square. Q cube minus 6t square. This was the expression for the displacement in terms of time t given to us. Find acceleration. Find acceleration when the body is at rest. Find acceleration when the body is at rest. Observe, this was the expression given to us. Displacement time expression was given to us. And he is asking acceleration. His concentration is on the acceleration when the body is at rest. Clear? Okay. No. Observe statement carefully. Body is at rest. Let us solve this problem. Body is at rest means what? Velocity is 0. Body is at rest means no velocity, 0 velocity. Here I clearly write. Body is at rest means 0 velocity. 0 velocity. Velocity is 0. V bar is 0. No velocity at all. It is taking rest. At rest, no velocity. 0 velocity. Okay. Now, he has given the displacement expression. S is equal to t cube minus 6t square. If we differentiate the displacement with respect to time, ds by dt, we get velocity. If we equate that velocity is equal to 0, then body is at rest. So let us take up the expression. Given expression is S is t cube minus 6t square. From this, velocity is what? V bar is ds by dt. we have to differentiate it. Differentiation of this is 3t square minus 6 into 2t. T square differentiation is 2t. T cube is 3t square. So it becomes, V bar becomes 3t square minus 3t square minus 12t. This is velocity. This is velocity. Here. Now, at rest, V bar is 0, velocity is 0. So this entire expression becomes 0. This entire expression 3t square minus 12t becomes 0. Then common here is 3t. So bracket t minus 4 becomes 0. From this we get t is equal to 0, I or t is equal to 4 seconds. You solve, we'll get t is equal to 0 or t is equal to 4. That means velocity is becoming 0. Velocity is 0 at t is equal to 0 seconds. Or velocity is 0 at t is equal to 4 seconds. That means body is at rest at t is equal to 0 seconds. Or body is at rest at t is equal to 4 seconds. Is it clear? At t is equal to 0 seconds, body is at rest. That means velocity is 0. At t is equal to 4 seconds, body is at rest. Velocity is becoming 0. Okay. Now, E requires acceleration. E requires the acceleration. So, acceleration A bar is simply given as dv by dt. dv by dt. This is the expression for acceleration calculation. Okay. Now, what was the velocity expression earlier we got? Velocity expression was, that is 3t square minus 12t we got velocity expression. If I differentiate it, so acceleration dv bar by dt. If I differentiate it, 60 minus 12. This is the expression for acceleration. If I differentiate this expression with respect to time, velocity expression, if I differentiate this expression with respect to time, I will get acceleration. dv bar by dt is acceleration. So 3t square differentiation is 60. 12t differentiation is 12. 60 minus 12. That is the acceleration. Okay. Now, what he says, E requires acceleration when the body is at rest. That means here there are two cases. Number one, observe. Number one, when t is equal to 0, body is at rest. When time is equal to 0, body is at rest. That means velocity is becoming 0. In the bracket I am putting velocity is becoming 0. Then acceleration is, what is the expression for the acceleration we got? 60 minus 12. Substitute in this term t. If I substitute 0, so 6 into 0 minus 12. So acceleration becomes minus 12 meter per second. When time t is equal to 0, body is at rest. V is 0, velocity is 0. Acceleration expression already we know. This expression we know, we have calculated just now. And in that t is equal to 0, if you substitute 6 into 0 minus 12 meter per second square acceleration. We got it. Minus sign indicate retardation, negative acceleration. Clear? Now, second case is body is also rest. body is also at rest when t is equal to 4 seconds. When t is equal to 4 seconds, body is at rest. That means velocity v bar is becoming 0. Same acceleration expression we got is 60 minus 12. Substitute in this in place of time t. In place of time t, substitute 4 seconds. So then it becomes 6 into 4 minus 12. So it becomes plus 12 meter per second square. So this is the acceleration 12. When t is equal to 0, we got minus 12 meter per second square. At that time also body was at rest. Velocity was 0 at that time. When t is equal to 4 seconds also, body was at rest. Velocity became 0. At that time also, acceleration from the same expression, we got as 12 meter per second square. So this is how we calculated first displacement equation was given. Observe the steps here. First, observe the steps here. First, displacement expression was given. From the displacement expression, we differentiated it. From there, we got velocity. Now, from that velocity expression, he is asking body is at rest. So, velocity expression was equated to 0. So, from that, we got time t is equal to 0, t is equal to 4 seconds. And from the velocity expression, we got acceleration by differentiating it. Then from t is equal to 0 and t is equal to 4 seconds, if we have substituted in the acceleration expression, we got accelerations the body is at rest. Is it clear? So that was the expression it says. Okay. Now, let me take up a third numerical. Third one. Okay. S is equal to 3t I cap plus 4t j cap. Find number 1, velocity. Find velocity at t is equal to 1 second. T is equal to 1 second. Next bit is asking speed at t is equal to 1 second. T is equal to 1 second. Third bit is asking, C bit, acceleration at t is equal to 2 seconds. These are the three things he is asking. He has given displacement expression in the vectorial form. Observe, in the vector form he has given 3t I cap plus 4t j cap. He is asking velocity at 1 second, speed at 1 second, acceleration at 2 seconds. Is interesting. Clear? Now let us solve this problem first. Let us see the expression. Expression what he has given, S is equal to 3t I cap plus 4t j cap. This is a vector form notation he has given. Displacement is expressed in the vectorial form, where I bar I cap and j cap are unit vectors along x direction and y direction. I cap is a unit vector along x direction, j cap is unit vector along y direction. Clear? That means, suppose A bar is a vector, suppose, let us say, A bar is a vector, then AX I bar plus AY J bar. It is in this form, where AX is a component of A vector along the x-axis, AY is a component of vector A along y-axis, and I cap, j cap are unit vectors along x direction and y direction. Here, now, if I express this yes in the same manner, S bar is Sx I cap plus Sy j cap. This is the vectorial form. Clear? Where Sx is a component of S along x-axis, where Sy is a component along y-axis, and I bar, I cap, and j cap are unit vectors along x and y direction. Clear? No. Clearly, it is in the xy. That means it is a two-dimensional motion. Given is a two-dimensional motion. It is 2D motion. Two-dimensional motion. It is two-dimensional. This is a example I have given. This is example vector notation I have given. Okay. This is a two-dimensional motion. That means in the x direction and the y direction. Okay. That means displacement is in the x direction, displacement is Sx, y direction displacement is S. Okay. Now observe S bar, okay, that is given as 3T I cap plus 4T J cap. If I compare this, Sx I cap plus Sy J cap, then Sx is equal to 3T. On comparison, just observe, on comparison, and Sy is equal to 4T. So this term is Sx, this term is Sy. Okay? So Sx, Sy are the displacement where Sx, Sy are displacements along x and y directions. X and y directions. Is it clear? That was given. Okay. Now, we need velocity. Sx is 3T given. Velocity is what? Vx bar. So, ds by dt. Differentiate this one. This becomes 3. This becomes 3. Clear? We want the velocity. So, it becomes 3. Similarly, Sy was given 4t. Differentiate it. So v bar y, velocity in y direction, ds by dt. If we differentiate, this becomes with respect to time t. So it becomes 4. So vx bar, vy bar, after differentiating sx, sy with respect to time, we got it. This is first step. This is the second step. Now velocity we require in the vectorial notation. So vectorial notation, v bar velocity is vx bar I cap plus vy bar j cap. Very clear. So vx is how much we got? 3. So 3 I bar we got plus vy how much? Vy bar how much we got? 4. 4 g bar. Clear? 3i plus 4. Is there any time term here? No time term is really involved. So here I clearly write velocity is not time dependent. Not time dependent here. There is no time term. So velocity is independent of time here in this expression. There is no time. Not time dependent. Yeah. Now, magnitude of velocity. V bar is already 3 I bar plus 4 G bar. So, magnitude of velocity is modulus of V bar. So, modulus is 3 square, coefficient of this square plus coefficient of this 4 square. So, it becomes under root of 25. Becomes 5 meter per second. 5 meter per second. This is magnitude of velocity. Magnitude of velocity. 5 meter per second. Clear? 5 meter per second. Magnitude of velocity itself is nothing but speed. Speed is nothing but magnitude of velocity. Okay. So, he has asked velocity at t is equal to 1 second. Speed at t is equal to 1 second. But in the velocity expression, there is no time. So it is not time dependent. Hence, velocity was given as in the vectorial form. This is the velocity. This is velocity. That was vectorial form. There is no time at all. So it is a time independent of time. Magnitude of velocity itself is a speed. That is also, speed is also not time dependent. Speed also not time dependent because there is no time term in this expression. Yeah. Okay. Is it clear? No. Observe. It requires acceleration. Third bit C is acceleration. Acceleration. It requires. So Vx bar, we know how much we got. It is 3. And Vy bar, we got how much? It is 4. What is the acceleration? Ax bar is dv by dt. dv bar by dt. So differentiate this in x direction with respect to time t. So it becomes 0. Constant differentiation is 0. Similarly, ay bar is dv bar by dt. Differentiate this expression with respect to time in y direction. 4 is a constant, differentiation is 0. So that means in the both the case, ax bar is 0, ay bar is 0. So in the vectorial form, a bar is ax bar I cap plus ay bar j cap. This is the expression, the vectorial form. But both are 0 I bar. Ax is 0 plus ay is also 0. So 0 j bar. 0 j bar. So magnitude of acceleration is also 0. Magnitude of acceleration is also 0. Magnitude of acceleration bar magnitude is 0 meter per second square. Units must you got to express, though it is 0, to express the units 0 meter per second square. Okay, and be careful. Acceleration is also independent of time. There is no time related to it. That's why acceleration in this case is not time dependent. In this case, I'm underlining the word in this case, not time dependent. There is no time in the velocity expression. There is no time word term, and in the acceleration also expression there is no time term. Hence, velocity, speed, though he has asked to calculate t is equal to 1 second, t is equal to 1 second, acceleration at t is equal to 2 seconds. There is no time term, hence it is time independent. Okay, so no need of putting the t is equal to 1 second, t is equal to 1 second, t is equal to 2 seconds. There is no time term. Is it clear? So, hope you have understood the numericals. Okay, practice well. Continuous efforts. If you put slowly, you will get confidence. Finally, if you like the video, please share it, subscribe the channel.